Welcome. How are you? Welcome to this tutorial whereby we're going to handle a revision of a question basically in the topic of indices and logarithms, and I shall be your tutor, Joseph Adeli. Before we begin, let's have a quick word of prayer. Father, Lord in heaven, we invite in this session that you're able to take lead as we review on a question that shall guide us in understanding a particular concept in indices and logarithms. We pray that you may be able to give us insight. You being the greatest mathematician, to take the lead. Just may pray. Amen. Basically, the question that you did using logarithm tables only, evaluate that specific question. Now, I took keen interest in it basically because of some few things that I saw that are quite critical, and from the look of things, basically in indices and logarithms, it now remains a review. I saw that you have an idea, yes, but there are some specific things that if you don't know how to apply them, they shall end up being theories and things that are only found in books. So we shall do a review of indices and logarithms, most probably such that you may be able to have them back at your fingertips and be able to be well acquainted with the concept. So basically, let's handle this question so that you may know how to answer such questions in future, so that if you get such, you can be able to go about them as you await the review of indices and logarithms. Basically, what is the solution? If you are given such a question, first of all, you need to rewrite that question in terms of indices, whereby you are working here. Let me just get it. This is the original question whereby you have the root sign, but I can rewrite it in terms of indices such that I now have it multiplied to a specific power, because with that I can be able to easily know how to be able to tackle this question. You shall see that as we progress why I mean it's much more easier tackling it with the indices form. So basically, you come up with a table, and in that table I'll be writing my specific numbers here, whereby the first one I've already written it here, 849.6, which is the first number. So each of these numbers must feature in this column, and you'll be writing them in various formats, standard form, log, and all other things. So we begin with the first number, 849.6. Writing it in standard form such that it's the standard form, you'll basically have a number that you can read from the log tables. So I'll basically have 8.496 multiplied by 10 power 2. So basically, up to this point, it will just be a normal mathematical logic. So what happens in a logarithm? We have two types. We have the structure contains of two sides, whereby the first side is what you call the characteristic, the second part is what you call the mantissa. Now, the characteristic, if I just use this as an example, not that is the literal one, assuming that this 8.496, or let me just write a number here, 4.327. Let me say like that number, 4.327. 4, if this is my log, 4 is what we term as the characteristic, and 327 is what we call the mantissa. Now, the characteristic is determined by the power of your number in standard form, the power of 10. So for example, here, if I have 8.496 multiplied by 10 power 2, the 2 there shall be the characteristic. Why do I say a characteristic? It shall determine the nature of the number you expect from that logarithm when you get the antilog. And basically, you'll see why we specifically say so. So the characteristic will determine, is it positive or negative? How shall it affect that number? Will it be of a particular nature, let me say so, multiplied by a specific scalar or something of the sort? That is basically what determines the characteristic. And the mantissa is basically what the logarithm of that specific number is. So in this case, 2 shall basically be my characteristic. and it's positive, so there's no need of writing the positive sign. You can just have the positive sign there, but because it's positive, there's no need of writing the positive sign there. So we'll basically now go to the log tables and be able to check what 8.496 is from the log tables. So confirming that 8.4, because that's what you have, 8.496. So 8.4 is here. So check 8.4 in that specific row. What do we have? 8.4. So as I read, I'll be reading 8.4 in this direction as I check the numbers here. So always check the numbers at the top. So 8.4, where is 4? 4 is here. So I'll move down with this column until where I'll meet the row 8.4, which shall take me to, not 4, I'll come to 9, 8.496. You should remember the number. So it's 8.496 shall meet me at this number here. It's basically the structure that we have like matrices, or basically coordinate system. That's how you read the log table. So you'll first read the first number, 8.4, from the first column of your log table. Then the second decimal point, you shall read it from the numbers that are of specific columns. But what about this 6? Notice now we have read 8.49, it's remaining 6. You will now come to the additional segment of the table. I'll now check where 6 is. 6 is here. And then I'll move with 6 until I'll meet 8.4 row. It will take me to 3. Now what happens to this 3? This 3 shall be added to the number, or let me not say number, it shall be added to the mantissa of the logarithm that we'll have created. So we'll carry now our new number here will be 0.9289. You add 3 and then sum up to the characteristic, which was 2. You'll basically now lead to 2.99292 because you have added 3. Now why do we add 3? Follow the instruction here. It's not something that is predetermined. Some of them you'll find that they say subtract, some of them will say add. So depending with what you basically have is what you are going to use. So here we have been told add 3. So after adding 3 you'll have 2.9292. We are now done with the first number, getting the logarithm. Basically we want to have each of them in log form, which shall be easier to work out with addition and subtractions. Next number is 2.41. Standard form, that shall be still 2.41 multiplied by 10 power 0. So what shall be our characteristic? You can just have a wild guess. The characteristic shall be 0. So it being 0, let's get the mantissa part. So it's 2.41. 2.4 is here. And then check where 1 is, the 1 column. That shall be 3820. And then because there's no other value that you need to check, you pick it the way it is. So it shall be 380. So we shall basically have 380 here, and we drop the other value here. Why do we drop it? Let's get the logic here. We have a number here that is being multiplied. We escaped the multiplication because we have only been restricted to use tables. So we have to use indices to be able to solve this question. Where does indices come in? If you have a multiplication of numbers, their logarithms will basically add. That shall be easier to work with. So if I get the logarithm of 2.41 and the logarithm of 849.6, and I'll be able to get the multiplication here in terms of logs by adding them up. So what I'll specifically come and do here is, I have my new log here, 0.3820, sum it to the other value there. And why do I sum it? I've specifically said if you have multiplication in indices, if we have logarithms. If there's multiplication of numbers, their specific logarithms will add. So we'll basically come and add the numbers and we'll end up having 3.3112. After having that, now we have now completed the numerator part. And basically know that we are following this. So all of them are still the same, but we want to follow this because the indices will help us note where we are. So we are done with the numerator part. Because the logarithm of the numerator shall specifically add up to 3.3112. Let's go to the denominator, which is 3941. In standard form, it shall be 3.941 multiplied by 10 power 3. The characteristic is 3, which will be 3, and there are some mantissa part. So reading that, 3.941, I believe I got it right, 3.941, shall come here and read, where is 3.9? 3.9 is here. So 3.9, where is the column 4? 3.94. So I'll read 59, 55, 1. I come to the 1 column of the additionals. I've been told 1, but what do I do with 1? I sum it up, I add it. So I shall pick 59, 55, add 1 to the mantissa part, then sum it to the characteristic, and basically I'll end up with 3.5956. Now this, notice this line. What does this line mean? This line means division. So it means whatever I have at the top here, I need to divide with the bottom part, but we are working with the logarithms. If you're working with the logarithms, division, the log of the number that you are dividing shall be a subtraction. So that is one of the things you need to know. So whenever you are having a division of numbers, their specific logarithms shall be subtractions. So basically I'll drop 3.3112. To dropping that, I also bring 3.5956 closer to it. But what will happen? We have said, because their numbers, the specific numbers are dividing, we shall do a subtraction. So after subtracting that, you'll end up with 1.7156, which shall be the number. But it's not 1. There's a bar. That's something you need to note. This line here you see here is a bar. So it's a bar. What does the bar mean? It means 1 is negative, but it does not affect the mantissa. The 1 is negative, but the other part is positive. That's why we have bar 1. But if we write a number like this, negative 1.7156, this is different than to this, because the whole number here is negative. But if I have bar something, the bar part is the only one that is negative, the rest are positive. So specifically, I'll come up to the last section. I have a multiplication of a third. Why? We have gotten everything in this bracket in log form. We are remaining with the power. Now, under indices, what did we say? If I'm having a power, or I'm having a specific number brought to a specific power, what happens to the logarithms? The logarithm will multiply with that power. I believe you are getting that right. If I'm having a logarithm of a number whereby that specific number is being multiplied to a specific power, that power shall multiply directly the specific log, whereby the number that is in this bracket, its specific log is bar 1.756. We multiply that with a third, but this number, notice it's being raised to a power of a third. So if I work this out, I'll notice one challenge first. You cannot divide this bar 1 and every number here by 3 and have a complete number. So to solve this one out, I'll now ensure that the bar part, the negative number remains, the negative characteristic remains negative all through. How will I do that? I'll split these numbers into 2. I'll end up with bar 1 plus 0.7156. I've not included that in the slide, but that's what you need to know. I'll end up with bar 1 plus 0.7156. So I'll borrow a value from bar 1 such that it gives me a number that is wholly divisible by 3, and that number that I've borrowed, I'll add it to the number. So basically, let me just sketch what I'm saying here. I'll end up with bar 1 plus 0.7156. This is what I'll have at the following step here, and everything is divisible by 3. So what will happen from this step? I'll borrow a number here. I can borrow 2, I can borrow 5, whichever it is. So it's better to borrow the least one so that you can have an easy task of division. So if I borrow 2 here, what will come up? Notice naongeza deni. I'm increasing the debt. So if I'm increasing the debt, it means it gets more negative. So if I borrow 2, I'll end up with bar 3 plus that 2, you now bring it to the characteristic. Notice that there will be no change. The number that will be still be the same. 7156. And this is what we are going to divide by 3. So this is what will now sum up our things. So notice if I work this new number I've written here, it is simply coming to bar 1. There's no difference that I've done. I've only ensured that the negative part remains with the characteristic. So if I divide all through, I'll end up with this value. I believe that's clear. You can pick that from the previous number that you have come from the red part on the right part of the screen to what we sum up here. So if I divide all through, I'll end up with bar 1 plus 0.9052, and if I solve that out, gives me bar 1.9052. Now up to here we now have the solution of this. The solution here is simply bar 1.9052, but there's something that needs to be done to this number, because there's no number that you'll ever see with a bar that is natural. This is a logarithmic number, so we have to do an anti-log to have a number that is clearly to this. So basically denote in your table, you are getting now the anti-log of bar 1.9052, such that if somebody is looking at your steps, the steps are clearly demarked. So I'll have my number in that form. So bar 1 shall give me the power. Notice the first point, we said that the power of 10 gives us the characteristic. Therefore, the characteristic, if it is bar 1, which is simply means it's negative, shall give us the power of 10. So that is already determined. The number that you'll have will be this unknown value here multiplied by 10 power negative 1. So let's check in our anti-log what will be 0.9052 representing. So 90, I'll come to 0.90 here at the first column, and then I'll still follow up with that row to be able to know which value am I dealing with. So 9052. So I'll come under 5, the fifth column, and then I'll notice that I am working with 8.035, but there's also something remaining, 2. That 2, I'll come and check under the 2 column, which I'll have 4. But what is the instruction? I add. So that is the main instruction. I'll take 8.052, sum up the characteristics by 4, and I'll end up with a value that's multiplied by 10 power negative 1. That's what I have here. So it's 8.035 plus 4, which simply will give me 8.039 multiplied by 10 power negative 1. So my number shall come to 0.8039. So that is the answer that I have to this question, but we have to prove our answer. How do you prove our answer? I calculated earlier, and I believe from the workings you saw the structure of how I did the working. So here is just the proof. You can punch it in your calculator. My calculator is quite advanced, so I just punched everything in one step, but using yours you'll have to punch each number in your question individually. So by proving that, notice I have everything in my equation. I just press equals, and by pressing equals I'll notice that my number is 0.8039117391. That is basically my number, which is equal to the answer that we have, only that in logarithms it will be to 4 decimal places But in the calculator, you'll find that most of them you'll require either to truncate or round off so that you may have a value of the calculator. So the calculator here is only to prove our answer, not to get the answer, because you have been tied to the condition, the instruction that you are to use the tables only. So this is just to prove, and basically that now tells us that the answer that we have is correct by checking the answer in the calculator, because it's closer to it. They are almost equal, and the symbol for almost equal is basically that this is approximately equal to, or yeah, either of that. So therefore the proof at hand, with the proof at hand, we can now affirm that 0.8039 is the answer that we have gotten from the log table, that is equal to the value that we have. So therefore, success in your preparation, and may God bless you abundantly.